Welcome to Let's Good Games. 3 years ago I started this channel and I wanted to create a big tutorial series. Actually make a big game that shows some of the concepts how to structure a bigger game, not just like a small tutorial like you would see on YouTube or wherever you see those a lot. But I wanted to make a tutorial series that actually shows how you would architect a whole game. And I did this for a couple months, then lost track, lost momentum, and always wanted to start up again. Last November I made a plan, I wanted to start up again, and I started with this racing tutorial, which was great, but after I did this, I realized the racing tutorial is kind of what already exists out there. So many small tutorials about small genres. And I wanted to go back to the Zelda series, and actually there were a lot of comments asking me to go back to the Zelda series. So today I'm finally making it happen, going back into the Zelda series. And I'm going to start off a little bit differently, because the series had a problem. When I started it, in the beginning I didn't quite know how to do all that stuff, and I streamed the first episode on Twitch, but I forgot to record it, so the first episode was lost, and people were asking me on all the other videos if I could recreate the first video so they can get into the series. So that's what I want to do today. Actually, luckily I have the code for the first series still, because it's on GitHub, for the first episode rather. So I'm just going to recreate that code and explain what it does, so that you can get into the series more easily, and then next time hopefully we can continue where we left off 3 years ago. Let's see quickly what the first episode did. So it was very simple. Basically we want to make a Zelda 3 type game, and in the first episode we basically just made the character move. You can see here there's a little animation playing, and I'll show you how to do that. And also we made the character move by using WASD, which sounds kind of simple, but we actually started to discuss a little bit how to architect this so you can later expand it more easily, like have keyboard controls, maybe have controller gamepad controls and stuff like that. I actually made a short video explaining this pattern, the model view control pattern that you can use to structure your code, and I will leave a link to that video at the end of this video so you can check it out. It explains the model view control pattern a little better. But yeah, in this video I'm just going to show you what we did in week 1. Okay, so let's jump over to a fresh Unity installation. There is nothing done in this project yet. I've just basically copied the sprite sheet for the walk cycle over here, and we can start right off. So let's look at the sprite sheet and how we can set this up. So the walk cycle is actually created in a very specific way. You can see here we have 4 different directions for the walk cycle, and they're laid out in a specific pattern. So the whole file is actually 1024 by 1024 pixels, and there are 8 by 8 characters, which means each character is laid out in a grid of 128 by 128 pixels, kind of like this. So, and the reason we did that is because Unity has a way to split up a sprite sheet like this, so we can use it as single animation. So we can use each character as a single animation frame. Let me show you how this is done. So we click the sprite sheet file here, and there you can see in the inspector on the right here there is some properties we can set up, and there's this button called sprite editor, and the sprite editor actually allows us to split this graphics up into multiple single characters. So first of all, we have to select the sprite mode. So the sprite mode right now is set to single, so the whole file is representing one single sprite, and we actually want to change that to multiple and apply this. And now we can start creating the different sprites here. You could actually just draw them around each character like this, but this is quite tedious to do. And since we've created the file in a specific grid, there's a much easier way to do this. So we simply click the slice button up here, and we select the grid type. And now we can actually tell Unity what the grid size is. In our case, it's 128 by 128 pixels. And then you can hit slice, and you see Unity automatically created the slices in the specific arrangement that we did. So that's already it. So hit apply here, and we can close the sprite editor. And now if we select this arrow here, we actually see each character, each animation as one single file that we can use. Okay, so let's use this to create our walk animation. So first of all, we create the base object for the character, and I have a very specific way to do that usually. So I create an empty game object for the new character. So I go to game object, create empty, and I just call him Lunk, I think that was his name. And I never create the visuals of the character on this base game object. I always make it a child of the object. So let's do that here. Let's quickly check how we did it in the actual file. So I go back to the other Unity version. Okay, so the character was called Lunk, and then as a child we actually created the walk cycle there. And so let's do that here as well. So I click the first sprite of the walk cycle and just simply drag it into the scene. So now I have the sprite in here, and now I parent that I make this sprite a child of the base object. And the reason I do that is because I want to separate the visuals of the character from the actual code. This makes it much easier later on to just switch the visuals. So maybe I have a second character I want to use, or I have an enemy character that uses the same movement and from this character. Then I could simply switch out the sprite sheet, and then I have a new character without affecting the rest of the object. Okay, so I actually want to center this. So let's center this to the character, and I reduce the size of the camera gizmo a little bit so it doesn't block our character. Okay. So to create an animation, we actually can go to the animation window. So go to Window, Animation, and you can hit Control-6 as well to do that. And you can see here, even though we've selected the character, usually the animations would show up here, but we don't have any yet. So we can create a new clip. That is one way to do it, and then we could drag in the different animations. But actually a simpler way to create a walking animation like this is to select all the sprites in the animation we want to do. So these are the first 8, and then drag all of them into the scene. So now Unity automatically presents me with the Create New Animation window, and I think I just put them here in the sprite folder for now. So walk animation down. And now Unity created the same object basically. It named it the same thing because the first frame is Lunk walk cycle _0. But you will see here, compared to the old one, in the old one you only had a sprite renderer, which means the character is drawn on screen. But the new one has the sprite renderer and an animator. And the animator is a component that helps us set up animation. And since we dragged all the sprites into the scene, when I press play now, you can see the character is already animated and the animation is immediately playing. So I want to use the animated sprite instead of the static one. Put that to center again, and then yeah, we created the animation. And that's really it, what we did in the first week in terms of the animation. I think we already set up the left, right, and up animation, but that's the same process. And in the video of the second week, we started hooking it up so the character actually turns. So for this first week recreation, we simply use this one walk cycle here. Okay, let's start making the character move with WASD. So first of all, we want to split our code into different chunks, into different logical chunks, and this is called the model view control pattern. Just as I said before, the model actually holds all the data of the character, like hit points, for example, and in our case, which movement direction, in which direction the character is moving, and the control file is basically handles the input and then tells the model in which direction the character should move, and then the view file updates the animation. So we have three different files for three different responsibilities, and the goal here is to make it easy to switch out these files independently. So for example, we could use the same input scheme and the same movement type, but we have a different visual, like an enemy visual, and then we just need to swap out the visual script and can leave the other two alone. Okay, so let's start with the model. So in the project view, I create a new script. So I right-click in the project and create C# script, and the name is character movement model. And this script is attached to the base object here. So I could actually click either add component and then character movement model, and it shows up here. Or I can simply drag the script file over here to add that. Okay, so let's open this up. So this is our script file, and Unity gives us a basic structure for this file. So it created the class, and we have a start method and an update method. The start method is called once in the beginning of the game, and update method is called once per frame, so we can do stuff like movement in there. So for this model, in the first week, we basically just made the character move, and we can tell it how fast it should move. So let's create a public speed variable so we can set up the speed in the inspector, how fast the character should move. And we have a private variable that denotes where the character, in which direction the character is moving. So let's call that movement direction. And we're creating a vector here so that the control file later on, the input file, can actually tell this model in which direction it should move. So let's set this up. So we have a public function set direction, and it takes a direction vector. And then we simply set the movement direction to this new direction that we're getting. So the game is actually in 2D, right? So that's why we use a vector2 direction here. A vector2 is basically a structure that has an x and a y coordinate. But since Unity is a 3D engine, the actual position is a 3D position of the character. Only the z component, the going backwards or forwards, is always set to 0 in a 2D game. So that's why in our code we're actually using a 2D direction, but in the very end we actually have to use a 3D vector to be able to update the position. So when we set a new direction here, a vector2 direction, we actually cast it to a vector3 and then just pass on the x and the y and then set the z to 0. And yeah, that's it for now. We come back to this class a little bit later, but let's create the input class now so we can actually set the direction. So the input class, for this I actually wanted to show a little bit of abstraction here, because you could have a gamepad input or a keyboard input, and I want to be able to structure the code in such a way that so it's easy to swap. So in order to do that, actually what I do is I create a base class, and the base class is called character movement base control. It's a mouthful, but basically the base class defines what types of actions we can do with the character. So in this case we define that we can set a direction. And yeah, and in order to do that, we need a reference to the movement model, right? Because we want to tell the movement model where we're going. So let's set up a reference to our model. We call that movement model. And in the awake function, so the awake function is actually similar to the start function, but it's awake is always called before start. So Unity calls all the awake functions and then calls all the start functions. So I use that fact to do different things in awake and start. So basically what I do in awake is setting up references and just initializing variables to their default values, but I never do anything with them in awake. So basically make sure that in awake everything is set up, and then in start I can start using it because then I know all the references are already set up. So in awake we want to get a reference to our character movement model. And then we want to define the interface that the classes that inherit from movement base control, so the different movement classes like keyboard or gamepad input, and we want to define the interface what they can use. So in this case, the only thing that they can do is they can set the direction of the model, getting a vector2 direction, and then we're passing this on to our movement model. Set direction. So this variable that we get here is passed on to the model. And the reason we do that is, so in the base class, all the interaction with other classes are set up. So the interface and what these classes can do. And then in the actual implementation, like in the keyboard class that implements the control scheme, we don't have to care about other files. We just use the interface that we set up in the base class. So this way we can tell ourselves what are the actions we can do, and then the base class handles all the actions and what actually needs to be done to execute those actions. Okay, so that is actually already the base class. Now we need the actual keyboard implementation. So let's create a new script called character movement keyboard control. And in this file, we actually make sure that we use the interface that we defined before. So instead of inheriting from model behavior, which is the base Unity component, we actually can inherit from character movement base control. Right? So the keyboard control class now inherits the interface from the base control. So what we can do now is we can call stuff like set direction, because that's what this class defines here. Okay, so let's check out how we did this. So basically, we create a function called update direction, which does everything that we want to do. So let's start by setting up an empty direction vector, and that's the vector that we want to pass on to the interface. We start off as 0, so basically when we don't touch anything, the direction should be set to 0, so the character stops moving. And now we can start implementing the input. So Unity has this input class, and for keyboard controls we can use the function getKey. And then we pass on a key code. So in this case, when W is pressed, then we want to set the new direction Y component to 1. So if we press W, Y is set to 1, which in our game means the character moves up. And we do this 3 more times, and we change some of the values. So for this, now we have S, and the S key actually should move down. And next up we have A, which means the character should move to the left. So the X component should be -1. And the key code D means the character should move to the right. So the X component is +1. And the last thing is we call the interface of our base class, and we set the direction to the new direction that we set up here. So basically, we determine that we create a new direction initialized at 0. Then we check if one of the 4 WASD buttons is pressed, and we're setting the appropriate value. And then we're passing this new direction on to our base class here, which then passes this value on to the movement model. Okay. So now we can press WASD, and the movement model gets the input via the setDirection method and stores it in the movement direction variable. So now we can use that to actually make the character move. So let's create a method called updateMovement. Actually, we don't need this. So updateMovement. And in this, first of all, we want to check if the movement direction is 0. In that case, we don't want to do anything. So usually return. Okay. So what I'm doing here is I'm checking for a condition. In this case, if the movement direction is 0. And if that's the case, I return off the function, I stop the function. And this is called an early out. And I usually design it such a way so the early outs are in the top of the function and basically return out before doing anything. I find this is quite easy to read code like this, because you see the function and then you see all the early outs in the top and then the actual stuff happening below that. So why do we want to early out when we're not moving to any direction? Well, basically, at the moment, when we set the direction is in the keyboard control here, we can actually move in 2 directions at the same time, right? We can press W, so the Y component is set to 1, and we can press D, for example, at the same time, and the X component is set to 1. So we have 1 to the top and 1 to the right. And this actually means the character moves diagonally, which is what we want. That's fine. But since both components are at 1, the diagonal vector actually has the length 1.4. So it's larger than if we just would to go in one direction. So the character would actually move faster diagonally than to the left or right alone, because it moves in both directions at the same time, at the same speed. That's not what we want. We actually want that the character is always moving the same speed. So what we can do to achieve that is we actually just normalize the movement vector. And normalize means we divide all the components of the vector, so in this case the x, y, and z components, by the length of the vector. Meaning the new length of the normalized length of this new vector is actually length 1. And for variables like this, like the movement direction, it's actually very beneficial to always have it at a length 1 or a length 0, because then we can multiply the speed later on and change the speed value, and we only have to do that in one position in the end in the code. So I show you how to do that. So basically we have normalized this vector here, so it's always at 1, except if the vector is completely 0, then we don't do anything. Normalizing means dividing by a value, and if the dividing by the length, and if the vector is 0, 0, 0, its length is 0, so we have to divide by 0, which we can't do. So that's why we have this early out here, and make sure that we don't normalize when the vector is actually 0. Okay, and now let's just move the character. So we call the transform component of this character and get the position value, and we actually simply add our movement direction. Then we multiply that by the speed that we set up here, so we can actually design in the Unity editor how fast the character goes. And one last thing, we multiply it by the time.deltatime. So this is called frame independent movement. Imagine I have a very fast computer that runs at 100 frames per second. So the update method, and well, let's put this in right here, because we want to call update movement from the update method. This would be called 100 times per second. If I don't do this, let's say the speed is 10, then I move the character 10 units 100 times in a second, which is very fast. But if I play the game on my laptop, for example, and it only runs at 30 times per second, then this method would be called 30 times. So in a second, the character would only move 30 units instead of 100 units. So depending on the frame rate, the character would actually move faster or slower, and we don't want that. So by adding the time delta time and multiplying this value by time delta time, we actually make sure that no matter what the frame rate of the game is, the character always moves the same distance in a second. Alright, that's actually it. So let's see what happens. So I have the movement model here, and I actually want to add my keyboard control to the same object. And let's set the speed to 5 and see what happens. So I press play, the character is moving, and when I press WASD, nothing is happening. Okay. Let's see why. Oh, okay. Okay, actually nothing is happening because I'm not calling the update direction method, so I have to add this, of course, in my update. Let's try again. Press play, and now I press D, and the character moves to the side, and with W and S, he moves up and down. Okay, so the last thing that we want to add is the view. We actually want to make sure that the character can move in different directions and look in different directions. And to do that, just to demonstrate that here, we actually do that in the second week on most of this, but we started the code here. So I will add a new animation, and I would just want to have the idle animation, so the character is not walking, so that I can show you how that works here. So let's just duplicate by hitting Control D or Command D on a Mac, and just have the idle animation down here. And now we can open the animator. There you go. And when we click on the walk cycle, you can actually see here Unity set up a default animation with our walk animation. So the walk animation is always playing. I actually want to add the idle animation in here. And once I do that, I can actually go back to the animation window animation here. And now I see I have the walk animation down, and I also have the idle animation down, because those are the two animation clips that are attached to the animator. So they're both shown up here. So I simply go to the idle animation down, and I delete all the frames here except the first one. So we simply leave the first frame, and that's the idle animation. The character just freezes. Okay, go to the animator, and in order to transition between the two animations, we actually have to create something called a transition. We right-click on the walk animation and click Make Transition, and then we click on the other animation clip we want to transition to. So that's in this case the idle animation. So we want to be able to transition from walking to idle, and also the other way around. So right-click the idle animation, Make Transition, and click on Walk. So you see the two arrows appearing here, showing us from which state we can go to which other state. Okay, so let's click on one of the transitions, and in the transition you can actually set up conditions. What is the condition that should make this transition happen? So the list is empty right now, so I can press plus here, but I can't do anything at the moment because I need to set up parameters for this animator that I can then later on use for the transitions as conditions. So go to the parameters tab up here, and I press plus, and I add a boolean, and the boolean is called isMoving. And I actually have two more parameters that we use in the second week that deal with the direction of the character. And those are actually floats, and they're called direction X and direction Y. So this way we can set these values to 1 or 0, and that represents in which direction the character should be facing. But for now we focus on the isMoving part. So let's click back on our transitions, and now you see in the conditions actually our parameters start showing up. So when do we want to transition from walking to idle? Well, basically when the value isMoving is set to false. So when isMoving is false, we want to transition to the idle animation, and in case of the other direction, so going to the other transition, when the isMoving value is set to true, we want to transition from idle to the walk animation. The other stuff you can see here, and we actually have a bunch of settings we can set up. Well, these settings, the default values usually look really nice in like a 3D model because we're blending between the animations. But since we're using a sprite animation here, blending really doesn't make sense. We just want to swap from walking to idle without any immediately, basically. So we can click the settings here, and first of all we say that this doesn't have an exit time, so it doesn't matter where in the animation it is, the transition can happen at any time. So we don't have a specific exit time, and the transition duration is 0 because it changes immediately. And we do the same thing for the other transition in the other direction. So that okay. So now I can show you this side by side. So first of all, when I press play, the character is not moving anymore, and that is because you can see when let's show this side by side. So when you press play, you can actually see in the animator which animation is playing. At the moment, the idle animation is playing. Usually, this is like a progress bar. So if the animation is longer, it slowly fills. So you know where in the animation it is. But since the idle animation is only one frame, it kind of yeah, spazzes out here. Okay, so and I can debug this without any code. I simply can click on the isMoving parameter here, and then you can see the transition happens. Now we're in the walk animation, and the walk animation is playing in the game view here. So this is a good way to test out your animation tree before actually starting to code, to see if everything is set up properly. So if I stop isMoving, the character's not moving anymore, and if I start isMoving, then it is moving again. And now I want to be able to set these values through my own code. So let me show you how to do that. I can actually leave it like this. So for this, I create a view component, and the view component is responsible to how the character looks. So this component is called character movement view, not surprisingly. And you can see here. So this state machine here, where we set up the transition between walking and idle, is actually part of the animator component. So when we created the animation, Unity set this up for us. And let me show you in the project. In this project here, we have an animation controller, which is this, and the animation controller holds all this data, like what are the animation clips we want to use, and what are the transitions between them. And this animation controller is used in the animator class, yeah, to animate the sprite renderer in this case. And we can access the animator component and tell it to set the different parameters that we set up. So let's add our view component that we just created, and then let's write the code for the view component. So first of all, we need a reference to the animator, just like we had a reference to the model here in the control class. In the view class, we need a reference to the animator, so we can tell it what to do. So let's do this a little bit differently. Let's create a public value called animator, and it's of type animator. And by doing this, you see here now we have, since this is a public variable, we can now set it in the inspector here. And the walk cycle has the animator component, so we drag this in, and now we have the reference set up here. We also need a way to know if we're moving or not, and we get that from the movement model. So let's get a reference to the movement model. And we do that the other way with getComponent. The reason why I have these different ways is because the movement model is actually on the same game object as the view. So I can simply use getComponent, but the animator is not on the same game object. So I could do so this way I can set up this reference, and I can tell Unity exactly which animator I want to use. So yeah, setting reference always in awake. We simply call getComponent again. And also, since the animator is public and we have to set this up in Unity, we can actually create a little warning for ourselves if we forget to do that. So if the animator is null, if we forgot to set it up, then we just create an error, animator not set up, and we disable ourselves, so there are no errors from accessing the animator, because the animator is empty in this case. So this is just a little fail-safe for us, so in case we forget to set up the animator reference. Okay, so we write an update, and we call this update direction. Well, I think I refactor this in the later weeks, but for now I use the same function names as I used in the first week. So we can get the direction from the movement model, and for that we need a getDirection method. We don't have that at the moment. So let's go over to the movement model, and in addition to the setDirection method, we also create a getDirection method, and we simply return direction, and we simply return the movement direction. So this way the view can know in which direction we're facing. So we have the getDirection method. We check if the direction is not 0, and then now we can actually set the parameters of the animator. So animator the variable that we set up at the top here. And we have methods like setFloat. So the first parameter is actually the ID or the name of the parameter. In our case, that was direction x. And we want to set the x value of our vector. And we do the same thing for direction y, and we set the direction, the y component of the direction vector. And the last thing is we want to set the isMoving variable as well. So we have animator, in this case it's a boolean, so we set boolean. We type in the name is, nope, not isMovement, is moving. And now we need a way to know if the character is moving. And we create a new function for that. We simply call it isMoving. So let's create that function in the model. It returns a boolean, isMoving, and basically the character is moving if the movement direction is not 0. Okay, so isMoving is set up properly. We pass it on to our animator, and now I think that should be it. So let's go over to Unity again, press play. So idle animation is playing, and once I start moving, nothing is happening yet. Well, let's see. I probably forgot some method again. Oh yeah, of course. I need to call the update direction method. Okay. Press play again. Character is idling, and when I press WASD, the character movement animation actually start. And that's it for week 1, really. That was the code that we did, and I hope you can jump into the series now much more easily. The next episode is already up. That's what I did 3 years ago, starting from week 2 of this series and continuing onwards. And the next video I'm going to make is basically we continue on from where we left off 3 years ago. So thank you for watching, and you can get the code and all the assets from our Git repository, and I'll link that down below in the description. And I hope to see you next time. Bye!